एन ऑन इक्वल्स टू लैम्डा टू एन टू, है ना। अब लैम्डा क्या है 0.693 बाई टी हाफ, राइट।
T half.
तो टी ऑन हाफ एन ऑन इक्वल्स टू 0.693 डिवाइड बाई टी टू हाफ, okay, एन टू. So this will be cancelled.
Okay, sir.
Is it clear? No?
Yes, sir. Thank you, sir.
तो ये पिनअप सर जो बोल रहे हैं उसका
ठीक है। अब
यस सर
ठीक है, is it okay now? Is it okay?
सर ठीक है सर।
ठीक है, okay. Now second is transient equilibrium. In transient equilibrium, so again same equation, n2t equals to n naught lambda 1 divided by lambda 2 minus lambda 1 exponential minus lambda 1 t minus exponential minus lambda 2 t. Now for this case also lambda 2 is greater than lambda 1, but not that much bigger. They are in same order. Suppose this is 100 years, this is 300 years. Okay, so but this transient equilibrium will not achieve at the beginning, but when t is large, since lambda 2 is greater than lambda 1, so this term will vanish first. Okay, so when t is large, so this term you can ignore, second term you can ignore. Then what you can write, n2t equals to, this term is ignored, so n naught exponential minus lambda 1 t, that is n on t, then you have lambda 1 divided by lambda 2 minus lambda 1. So in that, in transient equilibrium, n2 n on is not constant, okay, but n2 by n on t, that is lambda 1 minus lambda 1 divided by lambda 2 minus lambda 1. So see, these are constant, right? So in transient equilibrium, n2t divided by n on t, that is constant.
सर इट विल बी n नॉट t into lambda 1 ना
n naught into exponential minus lambda 1 t, that is nothing but n on, right?
ओके सर
Is it clear now?
सर एक्सपोनेंट की तो दोनों लैम्डा 2 वाली टर्म को ही इग्नोर करेंगे बस।
लैम्डा 2 बड़ा है, अब t जब ज्यादा होगा तो पहले ए टर्म वैनिश होगा ना, कि लैम्डा 2 इज बिगर देन लैम्डा 1. इज इट क्लियर?
सर वैनिश तो फिर एक्सपोनेंटली तो दोनों ही होनी चाहिए,
दोनों होगा, बट लैम्डा 2 लैम्डा 1 से बड़ा होगा तो पहले तो ये वैनिश होगा ना जब t लार्ज है, नहीं?
यस सर यस।
Okay, so if you have done, then I'll do a problem. Shall I erase?
नो सर।
हो जाएगा तो बताना मेरे को।
सर सेक्युलर इक्वेशन की एक बार फाइनल इक्वेशन लिख दीजिए, वो रह गई।
सेकुलर का
फाइनल इक्वेशन जो था।
हाँ सेकुलर का ये वाला लैम्डा 1 n on इक्वल्स टू लैम्डा 2 n2।
सर ये तो लिख लिया था, वो जो लेफ्ट में जो था ना लिखा हुआ जो करा था।
अच्छा, जो आपका lambda 2 much greater than lambda 1, ये वाला.
yes sir, yes sir.
और t on half
सर
much.
स्क्रीन से बार बार वीडियो आउट हो रहा है.
ठीक है, मैं लैब वाला पार्ट यूज करूंगा. ठीक है, उधर जाने से प्रॉब्लम हो रहा है. ठीक है, तो मैं यहाँ लिखूंगा, तब कोई प्रॉब्लम नहीं होगा.
पिन करो सर, पिन करो.
हैं पिन तो है.
इस पिन नहीं है, वो सतीश सर ही कर सकते हैं.
नहीं, वो किया था सतीश सर जी, बट प्रॉब्लम हो रहा है एक्चुअली. मेरा वो जो दूसरा सॉफ्टवेयर ये
अपना अपना पिन कर लो सब लोग. क्या
ओके, हो गया ये.
यस सर.
ओके, ठीक है. आप प्रॉब्लम देता हो है ना, प्रॉब्लम करो. Suppose you have A nuclei decays to B, B decays to C, and C is stable. Okay, its decay constant is lambda. This decay constant is 10 lambda. Now calculate. Suppose this number is n on t. This is n to t after time t. This is n3 t. So listen that problem. A decays to B with decay constant lambda, B decays to C with decay constant 10 lambda, and C is stable. After time t, the number of n nuclei become n on t. This is n to t, and C becomes n3 t. So you have to calculate the ratio n to t divided by n on t. Is how much? So what about n on? And let us assume that A nuclei initially there is only A nuclei, that is n naught, B is 0, C is 0. So initially number of N nuclei is n naught, B is 0, C is 0. After time t, A become n on t, B become n to t, C become n3 t. So n to t by n on t you have to calculate. So n on t will be how much? N naught exponential minus lambda t, and n to t will be how much? N naught lambda divided by 9 lambda, right? Exponential minus lambda t minus exponential minus 10 lambda t, right? So if you take, this is your first equation and this is your second equation. Okay, so अगर 2 से on को divide करोगे तो आपको मिलेगा n2 divided by n on, and that will be how much? On by 9, then on minus exponential minus 9 lambda t. Okay.
सर
Yes.
यहाँ सेक्युलर इक्विलिब्रियम वाला फॉर्मूला यूज नहीं कर सकते?
नहीं, सेकुलर इक्विलिब्रियम का फॉर्मूला यूज नहीं कर सकते आप. सेकुलर इक्विलिब्रियम तभी यूज कर सकते हो, सपोज मान लो ये आपका, अगर इसका हाफ लाइफ 1000 ईयर है ना, और इसका आपका ओनली फ्यू मंथ्स, मतलब बहुत ज़्यादा बड़ा है, तब यूज कर सकते हो. ठीक है, सपोज मान लो इस डीके का हाफ लाइफ है आपका 1000 ईयर और इसका ओनली फ्यू मंथ. ठीक है, हाँ ठीक है. Shall I erase?
नो सर.
yes sir.
Okay. Again, similar type of problem. Similar type of problem. So initially, when time t equals to 0, you have only n naught. A nuclei is there. Okay, and this decay constant is lambda 1, lambda 2. Okay, so at time t equals to 0, there is only A nuclei, there is no B and C. At time t equals to t, there is A becomes n on t, B becomes n2t, and C becomes n3t. Now, if t is very small, if t is very small, you can say t is much smaller than 1 by lambda 1. Also, it is much smaller than 1 by lambda 2. Then you have to calculate n3t. Will be how much?
सर ये ब्रैकेट में क्या लिखा है? t is very smaller than
1 by lambda 1 and 1 by lambda 2. ओके, आपने लिख लिया प्रॉब्लम? हाँ, ओके। तो फिर आप n3 निकालना है। n3 का एक्सप्रेशन लिखो पहले। n3t was how much? n naught you have 1 minus lambda 2 by lambda 2 minus lambda 1, right? Exponential minus lambda 1 t plus lambda 1 divided by lambda 2 minus lambda 1 exponential minus lambda 2 t, right? This is your equation. Now is yes, you have question? So now now if you expand, since time is so small, so we'll expand up to quadratic term of time. So it will be 1 minus lambda 2 divided by lambda 2 minus lambda 1. So this will give you 1 minus lambda 1 t plus lambda 1 square t square by 2. Factorial 2 means 2. Now I'll ignore that higher order term because the time is so small. And similarly, I'll write lambda 1 for third term, lambda 1 divided by lambda 2 minus lambda 1, and here we'll have term 1 minus lambda 2 t plus lambda 2 square t square by 2. Okay, because there is factorial 2 that is same as 2. Now can we rearrange? So how much it will be? n naught, then you will have, see, this term, if you take this term and this term, so it will be how much? It will be simply
-1.
Exactly. So if you take this term and this term, it will be -1, right? 1 minus 1. Similarly, from this term, how much you will get? Plus lambda 1 lambda 2 divided by lambda 2 minus lambda 1. This and this term if you combine, you will get minus plus lambda 2 lambda 1 t divided by lambda 2 minus lambda 1. Similar, this term will be vanished with this. Okay, did you get what I'm saying? Then what about rest of the term? So from this term, you will how you can get common? So lambda 1 lambda 2 t square by 2 will be common. Okay, so what will be the rest? Lambda 2. Okay, in numerator you will get lambda 2. What about this term? So if you see this term, it will be how much? Minus lambda 1 divided by lambda 2 minus lambda 1. So this will be cancelled, this will be cancelled. So only left part is n naught. Then you will have lambda 1 lambda 2 t square by 2. Is it clear? Is it clear?
Yes sir.
कोई डाउट है इसमें? ओके, सबको समझ में आया? ये टर्म कैसे कैंसिल हुआ और कैसे कॉमन लिया? यहाँ से देखो लैम्डा 1 लैम्डा 2 कॉमन लोगे, लैम्डा 1 लैम्डा 2 टी स्क्वायर, तो यहाँ पे कितना बचा रहेगा? लैम्डा 2 डिवाइड बाय लैम्डा 2 माइनस लैम्डा 1। यहाँ पे कि अगर सेम कॉमन लोगे तो फिर क्या मिलेगा आपको? lambda 1 divided minus lambda 1 divided by lambda 2 minus lambda 1. So this will be vanish, 1 minus 1 will be vanish, so you will get only this factor. Okay, shall I proceed? Okay, okay,
Yes, sir.
okay. Now next problem. Next problem.
Yes.
Next problem. Suppose you have same a b equals to b equals to b equals to c, b equals to c. Half life of a is given. T half is how much? 10 hours. Okay, and half life of b is given. Half life of b is given, that is how much? 1.3 hours. Okay, so आपको calculate करना है time, at what time b becomes maximum, number of b nuclei becomes maximum.
सर इसमें मतलब टी हाफ दोनों का दिया है और we have
हाँ,
to find after what time b becomes maximum.
yes. So you can first you have to calculate it, because if you see time t prime was how much? 1 by lambda 2 minus lambda 1, then natural log of lambda 2 by or lambda 1, right? So you have to calculate lambda first. You know t half, so you can easily calculate that lambda, right? So lambda 1 will be how much? 0.693 divided by 10. Okay, per hour it will be. So it will be 0.0693 per hour. Okay, similarly lambda 2 will be how much? 0.693 divided by 1.3. Okay, so how much will get? 0.533 per hour. Okay, now if you calculate, now if you substitute it, then t prime will be how much? 1 divided by 0.533 minus 0.0693 natural log of 0.533 divided by 0.0693. Okay, if you calculate it, you will get 4.3 hour, 4.38 hour. Is it clear?
yes sir.
सर
Okay.
ये टी डैश कैसा निकाला मतलब it is the time at which b becomes maximum.
कल हम लोगों ने डिराइव किया था इसको कि at
Oh,
what
okay
time
sir,
that
okay.
b nuclei will be maximum.
Okay sir.
Okay. Now we'll discuss on important topic for your exam, that is alpha decay. Shall I erase this part?
Yes.
Okay. So there is a
सर टी डैश कितना आया था सर?
4.38 hours.
4.38 hours. Okay sir.
83 hours.
हाँ
4.83 था ना?
4.38.
38.
38.
हाँ ठीक है. Now we'll discuss alpha decay. अल्फा डीके अच्छे से करो, है ना. एक बार इस बार बहुत इजी क्वेश्चन आया था, शायद 30 सेकंड का था, 5 मार्क्स का था क्वेश्चन. तो सब अल्फा डीके कब होगा? जब साइज ऑफ न्यूक्लियस इज सो लार्ज एंड its मास नंबर इज ग्रेटर देन 150. सो मास नंबर अगर लार्ज है, ऑब्वियसली साइज विल बी लार्ज, राइट. So suppose you have a parent nuclei, its atomic number is Z, mass number is A, decaying alpha particle, so it will become Z minus 2, A minus 4, then you will have helium 2 plus, that is alpha particle. And there will be emission of energy. Since this process is spontaneous, and for all spontaneous process there will be energy of emission of energy, that is Q. If Q value is positive, that process is known as exothermic. And for all spontaneous process, that Q is positive. I'll calculate it also. So that is basically noted by Q alpha. I'll come to that point, why Q alpha used to say. So how will calculate that Q value? So Q will be how much? Q alpha will be how much? Mass of mass of y, sorry, mass of x minus mass of y
minus
mass of alpha particle into c square. So this will be your Q. Okay, amount of energy released. So suppose, so this particle is at rest and there is emission of energy. So that energy, suppose that amount of energy is around 4.26 MeV. So this energy will be distributed in the form of kinetic energy of this daughter nuclei plus alpha particle, but most of the energy will be carried in the form of kinetic energy of alpha particle. So suppose this energy is 4.26 MeV. So from this around 4.1 MeV will be carried by this particle as a kinetic energy. So that's why I used to write Q alpha. What does it mean? That most of the energy will be carried by alpha particle in the form of kinetic energy. I will derive it also. So is this clear? Now,
सर एक बार दोबारा बता दीजिए क्या आप
so in this process there will be emission of energy. So suppose there is a emission of energy that is 4.26 mega electron volt. So that energy will be in the form of kinetic energy of this particle plus this particle. Okay, but the kinetic energy, if it is 4.26, then from this 4.26, the contribution of helium particle as a kinetic energy, that is 4.1 MeV, and rest of the energy will be in the form of kinetic energy of daughter nuclei.
सर मैक्सिमम जितनी एनर्जी जाएगी वो अल्फा पार्टिकल में रहेगी.
हाँ, in the form of kinetic energy. Because why? Because you see this daughter nuclei is very big or it's very heavy, so it will have very.
सर जो रिमेनिंग काइनेटिक एनर्जी है
हाँ,
4.1 के अलावा
that will be in the form of kinetic energy of this particle, daughter nuclei. Why? Because I'll discuss also. Give me 3-4 minutes. See, this particle is so heavy, so it will have very less speed. If it has very less speed, obviously its kinetic energy will be less. So I'll derive it. Please give me 3 more minutes. Now we'll apply that conservation of momentum. So this is at rest. So how you can write? 0 from the conservation of linear momentum. 0 equals to, let us assume its speed is Vy and its speed is V alpha. So you can write My Vy, okay, plus M alpha V alpha. Okay, so from here you can write Vy equals to how much? Minus M alpha V alpha divided by My. Okay, now what will be the Q value, Q alpha, in the form of kinetic energy? What will be Q alpha? So if you remember, in the form of kinetic energy, that Q is nothing but kinetic energy of product minus kinetic energy of reactant. Since this is at rest, so there will be no kinetic energy. So Q value will be how much? Simply half M alpha V alpha square plus My Vy square. Is it clear? Is it clear? Okay. Now can you substitute that Vy in this equation? Can you substitute it? So if you substitute it and if you take common, so Q alpha will be how much? Half M alpha V alpha square plus half My. This will be minus M alpha V alpha divided by My square, right? So now we'll take half M alpha V alpha common. V alpha square common. If you take common, how much you will get here from here?
1
Simply
plus m alpha by m y.
MY. So this is the kinetic energy of alpha particle, right? And m alpha plus MY you will have, and also you will have MY. Now what about MY plus M alpha? Mass of y particle plus mass of this particle. So can we write like, how do you can write from here? Anyone?
So mx minus q.
So this is can you write like A into MP? A into MP? No. Mass of y particle will be how much? A minus 4 into MP. I am considering mass of proton is same as mass, right? And what about this? We can write it A minus 4 into MP. MP will be gone, right? No?
Yes, sir.
Is it clear
सर
to all?
एक और बार बता दो।
हाँ देखो, ये आपका इक्वेशन था x z a से y z minus 2 a minus 4 plus helium 2 4. So mass of y will be how much? I am considering mass of proton is similar to mass of neutron because they are almost same. So mass of y particle will be how much? A minus mass number into mass of a proton, okay, plus mass of alpha particle, that will be 4 times mass of proton. So a minus 4 into a minus 4 mp plus 4 mp, that will give you amp, and in denominator you will have only my, so that is nothing but a minus 4 mp. Is it clear now? समझ में आई नहीं?
यस सर,
हाँ.
यस सर।
सर
हम्म.
सर A-4 तो डाई एटॉमिक मास है ना सर Y का?
y का मास टोटल मास न्यूक्लियस का मास है.
यस सर, तो A-4 डायरेक्ट इनटू MP क्यों कर रहे हैं?
ये तो मास नंबर है ना, मास आपका है. ये मास कब मिलेगा? मास नंबर से अगर न्यूक्लियन का एक न्यूक्लियन का मास मल्टीप्लाई करोगे तभी आपको क्या मिलेगा? टोटल मास मिलेगा. ये आपका मास है, तो मास नंबर से आप एक न्यूक्लियन का मास नंबर मल्टीप्लाई करोगे तभी आपका ये मास मिलेगा. ठीक है?
ओके सर, ओके सर.
इज क्लियर नाउ? सो अब क्या मिलेगा आपको यहाँ से? काइनेटिक एनर्जी ऑफ अल्फा पार्टिकल कितना मिलेगा बताओ? सो a माइनस 4 बाई a इंटू क्यू ऑफ अल्फा. दिख रहा है? ठीक है ना?
Yes, sir.
Since a is large, see a is very large, okay, so that's why if a is large it will be almost unity, or you can say it will be 90 or 92% of total q. Okay, I'll give problem, you do it. Shall I erase?
सर ये काइनेटिक एनर्जी सपोज वो एग्जांपल के 4.1 के बराबर है.
हाँ, कितना?
तो
4.1 के
kinetic
बराबर आ रहा
energy-
है? नहीं, वो अभी करूंगा. एक ये तो डिपेंड करेगा कि
जैसे वो आप एग्जांपल लिया था ना 4.26 का, तो जैसे आपने बताया था कि 4.1 एनर्जी हीलियम में चली गई अल्फा पार्टिकल में,
हाँ
तो ये उस एनर्जी का एक्सप्रेशन है.
एग्जैक्टली. Shall I erase? समझ में आई है? बट
Yes, sir.
ठीक.
यस सर।
अब देखो, सपोज मान लो आपको पास से है थोरियम 232 डिकेस टू रेडियम 228 प्लस अल्फा पार्टिकल. ठीक है? सो क्यू वैल्यू गिवन है इस इक्वेशन का. क्यू कितना गिवन है? 500 किलो इलेक्ट्रॉन वोल्ट, एंड दे आस्क काइनेटिक एनर्जी ऑफ अल्फा पार्टिकल. ओके, सो वेरी सिंपल प्रॉब्लम. I will do kinetic energy of alpha particle will be how much?
A minus 4 by A.
So this will be 228 by 232 into 500 kilo electron volt. Okay, so if you calculate it, how much you will get? 491.3 kilo electron volt. Now you can understand. So from 500 kiloelectron volt, contribution of kinetic energy for alpha particle is 491.3. Okay.
Yes, sir.
Now we'll solve one more problem. So suppose similar kind of decay. Here mass number is 230, 226. Okay. Mass number 230, 226, and binding energy is given. Sorry, this is Ra. Okay, radium. This is Ra. So in this question, they have given the binding energy of radium, that is on 740.88 MeV. Binding energy of alpha particle given 28.3 mega electron volt. Okay, and binding energy of thorium given, that is on 743.7 MeV. इसमें पूछा गया है कि काइनेटिक एनर्जी जो है रेडियम का कितना है. ठीक है, डाटा हम लोगों ने नोट कर लिया. On 740.88, 28.3, then you have on 743.7. Shall I proceed for solution?
सर प्लस क्यू नहीं होगा?
जी
प्लस क्यू
नहीं, आपको ये सिर्फ बाइंडिंग एनर्जी प्रोवाइड किया गया है. आपको पूछा गया है काइनेटिक एनर्जी जो है आपका रेडियम का कितना होगा. ठीक है, तो देखिए बाइंडिंग एनर्जी से आप क्यू निकाल सकते हो, है ना. Binding energy of product minus binding energy of reactant, that is Q value, right? So if you calculate Q value, how much it will be actually?
25.48.
So you have to add this, then you have to subtract this, right? Please do it. So Q value will be how much? Q will be how much its was its binding energy, that was on 740.88, right? Then you have this helium or alpha particle, that is 28.3. Then this one has how much? On 743, right? 43.7, and of course that total unit will be mega electron volt. Okay. Now if you calculate it, you will get 25.48 mega electron volt. Now we can calculate kinetic energy of alpha particle. That will be 226 divided by 230 into Q alpha. Q alpha is 225.48. So this will give you 25.03 mega electron volt. Okay, and you know Q alpha, sorry, kinetic energy of alpha particle plus kinetic energy of radium, that should be equals to Q value. So kinetic energy of radium will be how much? Q minus kinetic energy of alpha particle. So it will be around 0.44 MeV. Is it clear? किसको समझ में नहीं आया? समझ में आया? Did you get any doubt?
Yes,
समझ में आया ना? ओके, चलो थोड़ा 5 मिनट का ब्रेक देते, ठीक है, फिर स्टार्ट करेंगे. ओके.
ओके.